Welcome to Physics Prep. This question is from TATA-GS 2019, and the situation in the question is that a plane, as shown here, is accelerating forward, and this acceleration combined with gravity, of course, creates a force on the particle of mass m here, as well as there is a friction, which of course opposes any motion. Now our job is to find the value of theta for which the mass remains at rest in the plane. In it, first we will consider the gravity, which of course goes straight downwards, and this gravity will have two components, one in the direction of the plane and we'll take another one perpendicular to it. Now if you look closely, we see that the theta should be located right here, which makes if this is mz, the gravity, then this side should be mz sine theta, and this one should be mz cosine of theta. Now if the acceleration, we have an acceleration here that goes forward, which means the force it provides will try to push the body this way. So this is the acceleration. We'll write ma here. For the acceleration, of course, this acceleration is again, we have to resolve this into two components, one on the plane and another one perpendicular to the plane that will be added to the gravitational force here. So in this case, our theta will be right here, ma cosine of theta, and the other one ma sine of theta. Now we have got the gravitational and the force due to acceleration as free body diagrams. The third force will be, of course, friction, which depends on the normal force, and normal force is written as N and is straight out perpendicular to the plane. The force of friction, let me write it as Ff, is equals to mu times this normal force. But before that, we notice that A is lesser than Z mu, which means A mu is lesser than Z. Now this tells us to consider the gravitational force as greater than the force due to acceleration on the plane. So we do mz sine theta minus ma cos theta. Since they are working in opposite direction, this difference is what makes the mass move. The mass moves because of this force, and we will have a counteracting force of friction, that is mu n, which makes the mass stop. So if these two forces are equal, then the body will not move at all. So now it's pretty simple. We just need to follow some algebra. mz sine theta minus ma cosine of theta is equals to mu times n is ma sine theta plus mz cosine of theta. So this gives us the m cancels off first, and then we'll take out the common by sine theta and cos theta, which gives me sine theta times z minus mu a equals cosine of theta times mu z plus a. Now we can write this as tan theta equals mu z plus a divided by z minus mu a. And if we write it just like it's written in one of the solutions, if we write it like it's written in one of the options, we will have theta equals tan inverse of mu z plus a divided by z minus mu a. So this is our answer.